All right, this is Algebra with Finance A, Unit 2, Lesson 6, Validity of Arguments. And this is an area of statistics that is really critical and very important, particularly as we look at the world of politics and some of the arguments that are made from both sides of the aisle on issues that are very important to us. There are a lot of these statistical misconceptions that are promulgated, that are promoted, that are used, and they kind of obscure or hide, obfuscate, so to speak, the truth. And so that's really important. And I'm not going to try to make any political points because that's an area that's not in the scope of this class. But I do want to point out the idea of making logical arguments based on as much data as you can possibly glean, and really collecting all the data on a subject before making a decision about a particular topic. So, for example, there is a concept called the confounding variable. Okay. The lesson doesn't mention this by name, but it does, confounding variable, it does have the concept. And confounding variables are factors that are going to affect your outcome, the outcome of your study, that are not necessarily directly measured or accounted for. Let me give you a case in point, right? When comparing two sets of data, I'm going to compare two sets of data. Shark attacks. Shark attacks are actually extremely rare, but shark attacks occur almost predominantly in the summer months, so August being the peak. Okay, that's where shark attacks occur. All right. Now, if you look at ice cream consumption, ice cream, everybody screams for ice cream. Ice cream consumption, and plot a graph, you would also see the same thing. While there is lots of ice cream consumption outside of the summer months, and particularly the month of August, are peak for ice cream attacks. All right, ice cream consumption. All right. Now, a bad statistician would make this logical assumption. And they would say ice cream causes shark attacks. Now, this is a preposterous conclusion, right? I hope you recognize this is preposterous. There's no way that ice cream consumption produces or causes shark attacks. This actually is an example of a mantra in statistics. Correlation is not causation. And that's very important to distinguish. Correlation is not causation. If you see a link between two pieces of data, that does not necessarily mean that one directly causes the other, right? So the fact that shark attacks and ice cream coincide in the same months, there are other confounding variables, right? Other confounding variables. If you really wanted to prove that ice cream causes shark attacks, you'd have to account for the confounding variable. And the confounding variable, I believe here, that is of most important is weather. Okay? Whether or not, whether it's sunny or hot, right? The weather has a very big impact on both of these items. In the summer months, when it is warm, people go to the beach and they swim in the ocean. Therefore, they encounter sharks more often and are more likely to be subject to shark attacks, which again, if you're scared of the beach, don't worry. Shark attacks, even in the summer months, are extremely rare. They just occur more frequently, relatively, than in the winter months when the people simply aren't in the water, right? And ice cream consumption goes up because it's a nice, sweet, cool treat that is great to enjoy when you are hot and sweaty. And who doesn't want to go when it's 110 degrees outside and go to an air-conditioned ice cream parlor and eat ice cream slowly and enjoy it? I'm getting hungry just thinking about it. Right? So weather is the common mitigating factor. And so if I wanted to determine whether or not ice cream causes shark attacks, I'd have to equalize that out. I'd have to control for the confounding variable. And so I'd have to compare ice cream consumption in the winter months with shark attacks in the winter months and try to control for weather and see if people that eat ice cream in the winter months are more subject to shark attacks. And I think, of course, you're going to find that as negative, that eating ice cream does not produce shark attacks. All right, so hopefully that makes sense. Confounding variables, correlation is not causation, and so forth and so on. And you can imagine the implications of that when we talk about various issues. One issue here, and I'm probably going to step into it a little bit, is wages of men and women. Right? It is commonly quoted that women earn about 80 cents on the dollar to what men earn. And the conception is that must be due to systemic and embedded race sexism, right? So that the jobs simply favor men, and there are confounding or mitigating factors that need to be considered. For example, the choices of men and women. There was a study done on railway workers, comparing men and women. Even in railway workers, it was unionized, and the wage scales are set. And so wage scales are not sexist at all, because if you work a given number of years, you have this particular pay. There is no merit-based pay, etc. But what they discovered was that the men and women in general, and this is not specific, any individual man and woman can make independent decisions, but in general, the tendency of men was to do things like take the overtime hours that were optional. So they would sign up for overtime hours and get time and a half pay, whereas more women than men would not do so. When it came to taking the shifts, like the midnight shifts on the train and stuff, the men were more likely to take these shifts, and the women were less likely to take these shifts. It's interesting that you can correlate children into the factor. Men with children are actually more likely to take overtime and to take undesirable shifts that pay more, with the idea, I think, that they would be needing to make more money to support their family. Women, on the other hand, are making the opposite decisions on the same issues. They don't want to take the midnight. Because someone has to be at home to take care of the kids, and whether that's not getting into the issue of men and women and roles in the household, but the women tend to make those decisions more, and those directly affect their pay. Now, you may have different opinions as to whether or not that should impact their pay. But these are the controlling or mitigating factors that need to be considered when considering something as complex as comparing wages between men and women. So those are the discussion points that need to be hit on. All right, some other things that are common is cherry picking. Now, cherry picking basically means you come across 15 studies. Say 14 studies that don't support your point and one study that does support your point, and you present just the one study that supports your point and ignore all the rest. That's cherry picking. All right, and that is a big no-no when it comes to statistical studies. If you really want to get to the bottom of something, you need to consider all the data. Consider all the reports on the subject. To bring in as much as you possibly can, and then look for correlations and what does the data support. And the final thing here is misrepresentation of data through misleading graphs. So for example, let's say I have two students, and I'm just going to give you a simple case here. Student A and student B. Student A scored 95% on the test. Student B scored 93% on the test. Now there's two ways I can create a bar graph to compare, and I'm just going to sketch. I could do this, and this is the misleading way. I could say 92, 93, 94, 95, and student A got a 95. Student B got a 93. And this graph makes it look like student B scored a lot less than student A, right? That there's a massive difference between the two. Whereas if I were to create a more realistic graph, starting at my scale at 0 and going to 100, right? Let's see if I can do this a little more accurately here. So 0, 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. Okay, and I were to sketch the graph that way, student A's bar would be 95%, so about halfway, and student B's would be 93%, still almost halfway to 100 here. And you can see that the comparison is much more realistic. So look for that when you see data. Are they presenting the graph in a way that is misleading, leading you to think that there's a massive difference when there is not? And there are other logical fallacies, but these are some of the things that need to be considered when studying any statistical study.